Hello, my name is Daniel Houston, and this is my Lab 2 Lines of Charge. In this lab, we're going to look at two pieces of clear Scotch tape and see their charges and how the transfer of electrons transfers between them. And we'll be using data from our Lab 1, which is recently seen in the last video. However, we will be changing the fact that the tape will not be looked at as a point charge, but as a series of charges, or a rod. These are a few assumptions that we'll make throughout this lab. First of all, we're going to ignore air resistance, so air resistance won't be a factor in this experiment. Next, we're not looking at tapes as a point charge, which is a significant difference from the last lab. And finally, the charges will be evenly distributed throughout the tape. And then these are a few equations that we'll need throughout the experiment, first of being Coulomb's law, and then the electric field formula, the relationship between electric force and field, and then the electric field for a rod. And as a reminder from the setup and the results of the experiment, we have the length of the tape to be 20 centimeters, the mass of the tape to be 0.0002 kilograms, and then the measured distance between the pieces of tape is 0.0258 meters. Now this is some of the calculations that I did to calculate the value for Q for a rod. And as you can see, we set the gravity equal to the electric force for the electric field of a rod. And we got the value of 2.409 times 10 to the 8th coulombs, which will be used later in the experiment. This is an outline of some of the code that I wrote for the model. And as you can see, we will be calculating the electric force on the top tape to the bottom tape by adding up the forces from each charge in the bottom tape as they interact with each charge in the top tape. And it is important to note that we ignore the interactions between the charges within each separate tape. And then you can see the setup for the electric field and the electric force for each of the sets of tape. And this is a diagram of all the forces interacting on the pieces of tape and the individual net charges on each of the pieces in the top tape. Now, what if we modeled each tape as a single point charge, similar to the previous lab? Each of these values would be slightly different, as with the single point charge, there's less of a value compared to the values from a charged rod because there's more charges to be measured. And why do these estimates differ? And which value is more likely to be closer to the real value and why? These values are different because the different approaches are used for each of the models. Lab 1 examines pieces of tape as point charges, while Lab 2 looks at the tapes as lines of charges. This gives a higher charge for Lab 2 because of the greater amount of protons and electrons. The line of charge closely resembles the tape because the distribution of charges is similar to what is actually happening. Thank you for watching my Lab 2.